Hi students, through a new series of videos, we are trying to bring a new approach for the students who are preparing for the CBSE Board Exam Chemistry. Okay, what we are doing is, we will be taking each lesson in chemistry, splitting it into different categories. For example, important definitions in the lesson, units in the lesson, examples in the lesson, numericals in the lesson, important conceptual question in the lesson, previous board exam questions, and also the important possible mistakes which can happen for the students while they write the questions from that lesson. Okay, so we will be starting with the first lesson, solutions. Okay, let's see. First, we can check about ideal solution. You already know what is ideal solution, right? Ideal solutions are the solutions which follow Raoult's law. Now, in exam, how they will give the question? Sometimes they will ask to write examples for ideal solution, or sometimes they will give a list of solution and you have to choose the ideal solution. In that case, how to choose ideal solution? See, this is the trick. Similar category of molecules form ideal solution. Similar category of molecules form ideal solution. Let us have a look. Okay, see, ideal solution here, right? You can see methanol and ethanol. Both are alcohols, similar category, right? Hexane, heptane. Same, both are alkanes, similar category. Bromo, ethane and chloroethane. Both are haloalkanes, right? Similar category. Benzene and toluene. Okay, see, both are aromatic with no functional group. Similar category, right? Hope you understand. So this is how you can you can choose the ideal solution from a list of solutions. The solutions which does not follow Raoult's law are known as non-ideal solution, correct? Before saying the trick, see, these are the examples mentioned for the different types of non-ideal solution. And basically, you know, there are two types of non-ideal solution. First one is the solutions which show negative deviation and the solutions which show positive deviation. And these are the four examples mentioned in the textbook for positive and negative deviation. Acetone and chloroform for negative, phenol and aniline for negative. You have to study this. It is from NCERT textbook. Ethanol and water, carbon disulfide and acetone. Okay, these are for the positive deviation. Hope you understand. Okay, you have to by heart these four examples which is mentioned in your textbook. High possible question, okay? But if they give a list of solutions and if you have to choose which one show positive deviation, there's a trick. See, the trick to identify the solutions which show positive deviation. This one. If one of the component of the solution is alcohol, carbon disulfide or CCl4, then that solution will be showing positive deviation. It's a very good trick. There are some few exceptions, but otherwise it's a very good trick. Okay, see, we can check some examples. See, acetone and carbon disulfide. Carbon disulfide is there, so positive deviation. Second example is an exception, okay? We can discuss it later. Carbon tetrachloride and toluene. So you can see CCl4, again, positive deviation. Here again, carbon tetrachloride and chloroform. You can see CCl4. Methanol and water, you can see alcohol. Acetone and ethanol, you can see alcohol. Ethanol and water, you can see alcohol. Okay, so in this, only one is exception. All other, if you check all other, you can see either CS2, CCl4, alcohol. Then, without thinking, you can go for positive deviation. Acetone and benzene studies as an exception. Regarding negative deviation, lot of examples are there, and I'm giving a small trick. Okay, actually you have to by heart, but I'm giving a small trick to identify which solution show negative deviation. See, if one of the component of the solution is an acid, then you can say that solution show negative deviation. Okay, if one of the component of the solution is an acid, then it shows negative deviation. Let us have a look. See, you take the last four examples, you can see water and methanoic acid. Acid is there. HCl and water. Acid is there. Acetic acid and pyridine. Acetic acid. Acid is there. HNO3 and water. Acid is there. HNO3, nitric acid, right? Now, first three examples, you have to by heart. There are exceptions. These are the examples of for non-volatile solute mentioned in the textbook. See, sodium chloride and mostly all ionic compounds, glucose, urea, cane sugar, etc. See, if you see these compounds as solute, you have to understand it's a non-volatile solute and definitely vapor pressure decreases. Okay, we know that if we add a non-volatile solute is added to a solvent, vapor pressure decreases. Okay, so these are the examples for the non-volatile solute. which result in the reduction of vapor pressure. Regarding colligative properties, colligative properties depends on the number of particles, and there are basically 4 important colligative properties mentioned in the textbook. You already know that, right? Relative lowering of vapor pressure, second, elevation of boiling point, and for that, see, this is an application for that which is mentioned in your NCERT textbook. Water boils at higher temperature than pure water. Salt water boils at a higher temperature than pure water. Okay, and the third colligative property is freezing point of depression. Adding antifreeze to water in car radiator. See, it's an example for what? Freezing point of depression. See, when you add ethylene glycol to water, the freezing point of the water decreases. Very important application mentioned in your textbook. See, now osmotic pressure. Okay, and it's an application, reverse osmosis in water purification. If you check any board exam, you can see some questions regarding azeotrope, and in your textbook there are 2 examples for azeotrope. Azeotropes, it is classified into 2. First one is minimum boiling azeotrope, and second one is what? Maximum boiling azeotrope. Regarding minimum boiling azeotrope, this is the example mentioned in the textbook. Ethanol and water mixture, and the composition is what? 95% ethanol. And second is maximum boiling azeotrope. It is hydrochloric acid and water mixture. See, 68% HCl. And you already know, right? If alcohol is there, it shows which deviation. If alcohol is there, then it shows positive deviation. And if acid is there, it shows negative deviation. That you keep in mind. In your textbook, these 2 examples for semi-permeable membrane is given. Naturally occurring semi-permeable membrane is pig's bladder or parchment, and synthetic semi-permeable membrane example is cellophane. Okay, it is from textbook, so learn it. In the section abnormal molecular mass, we learned the term association, and see this example we learned, right? Ethanoic acid. Okay, 2 ethanoic acid molecules stay together as dimer. Association, right? Association. Okay, now regarding dissociation, it is mostly ionic compounds, for example NaCl, Na2SO4, KCl, whatever. These are the examples for osmosis mentioned in your textbook. See, a raw mango, if you place it in concentrated salt, what will happen? See, it loses its water, it will shrink due to osmosis. Now next one is what? Wilted flowers revive. Wilted flowers revive back when you keep it in fresh water. Same for carrot also. When you keep it in fresh water, what happens? It becomes firm again. Hope you understand. Okay, these are the examples for osmosis. Okay, mentioned in your textbook. In the introduction of the lesson solution in the textbook, they have given this table. It's a classification of solution on the basis of state of solute and state of solvent. Okay, have a look through this table. Okay, you can see it's very easy table. You have to go through this table completely. Thank you all for watching this video, and this is the first video of this video series. We will be definitely back with a lot of videos from all the lessons. Okay, all the best for your preparation for the CBSE board exam. Thank you.